Hello, welcome everyone to our webinar. It's great to see so many people already joining. We're just going to give a couple of minutes for people to join, and we will begin in just 1 minute. So stay tuned. All right, seems there are quite a few people in. Maybe we can already begin with some housekeeping slides. So just to allow other people to join. So if we move to the next slide. Yeah, so the session will be recorded for all of you. So we'll send you a small, we'll send you the recording and also a PDF version of this entire presentation at the end of it. We are using Zoom Q&A for asking questions, so please type your questions in. We won't really use the raise hand feature in this particular session. And as always, we'll have a survey at the end of the webinar. So please do share your feedback. That's always super helpful. So let me do a little bit of an introduction of who you're going to see here today. So my name is Parikshit. I'm a part of the marketing team here at deepset. I am helping Sebastian run this webinar. And today we have Sebastian actually with us, who is your speaker for the day and who will guide you through the entire topic. He's the senior applied NLP engineer here at deepset. And yeah, Sebastian, nice to see you here. Thank you so much for doing the session. And yeah, maybe you can introduce the topic a little bit yourself and take it away from there.
Yeah, definitely. Thanks a lot, Perdy. As Perdy mentioned, my name is Sebastian. I'm a senior applied NLP engineer at deepset. I've been over here just about a year. And today I would like to talk to you all about practical insights into retrieval augmented generative question answering, in particular for enterprise search. This is the topic we have for today. It's going to get a bit technical, but hopefully provide a lot of nice tidbits for everyone to take home to improve their own systems. So without further ado, this is what I'd like to begin with. So just to demonstrate kind of what we've all seen with ChatGPT and what happens when you interact with these generative systems without something like retrieval augmentation. So, as a recent example of the news, we have like, what is the new name of Twitter after the rebrand? And in this case, I used Hugging Chat, but the same thing with ChatGPT. Obviously, it doesn't know the answer because this is a recent event and, these models were trained only up until recently. Now, if we have something like retrieval augmentation and a knowledge database to pull from, we can actually get the correct answer. In this case, we used our platform here on deepset Cloud. And unsurprisingly, we have the new name of Twitter after rebranding is X. So the idea is that retrieval augmentation can overcome these limitations that are just for generative question answering, where you're relying on the model's memory. And the big question here for us that we want to talk about today is like, how does this work? How does RAG QA work? So to kind of peel back the layers a little bit, I'd first like to start with, the steps in this process. So of course you ask your question. After that, we have the retrieving relevant information. So this is where the retrieval augmentation comes in. In this case, we have ingested a couple of news articles in our platform, and this part of the pipeline retrieves those articles that will then be fed to our generative model. So in this case, though, you can retrieve information from the web, internal documentation, confidential information. So any sources of information where, these models probably haven't seen before. And of course, once you have this retrieved information, the model is capable of reading this new context and then answering the question answering the question. And this is particularly relevant, again, for information that is not necessarily publicly available. So if you ever want to build a system on your internal documentation or sensitive IP, something like retrieval augmentation is basically necessary to get these systems to work well. Now, so first I'd like to dive into the retrieval part. How does this exactly work? So the retrieval part's kind of broken up into these multiple different components, and we try to leverage different technologies that currently exist to kind of maximize our benefit here. So the first thing I'd like to talk to you about is keyword search. This is a very canonical version of search. It's been around for a long time. Algorithms like TF-IDF or BM25. And even in the days of machine learning and neural net search, that these can still be very powerful, especially for very niche topics or things that are very keyword heavy. For example, product IDs. In e-commerce, oftentimes you'd like to be able to look up for your product ID. In this case, you need that exact match for the retrieval to work well. And this is just a guaranteed way of doing that. So, using keyword search, you can easily search for metadata and content. This works well with long and short passages. So things like splitting or splitting your document to shorter passages isn't as relevant. And, has a lot of well-established features like fuzzy matching to handle common misspellings, synonym search, and then, of course, metadata filtering. However, of course, it can't handle semantics very well. So like in this case, when someone refers to an EV, it won't make the connection that might refer to an electric car. So in some cases, semantic search can overcome these limitations, but it comes with its own set of cons. So the next system that we leverage here is, of course, semantic search, or what we like to call embedding retrievers. And this is where you convert your document into a vector and you use these vectors and compute similarities, which allows you to capture semantics. So in this case, when you ask the question, like, what are EVs? A system like this can leverage its knowledge to know that an EV is approximately the same as an electric car. So then you can retrieve documents about electric cars as well. So, these can also incorporate metadata. There are strategies for that. These only work with short passages for the most part, not always. There's some models out there that work with longer passages, but typically you have to limit yourself to about 300 to 400 words. To get meaningful semantics. And then, these models tend to be quite small compared to LLMs like ChatGPT. So they're relatively quick to run, which is nice. And there are strategies to circumvent the fact that you now have to use something maybe like a vector database to store these vectors. So by default, for example, something with a million documents with a default embedding retriever on Hugging Face might take up like 6 to 10 gigabytes of space. But you can use things like principal component analysis to shrink that. And we've done that actually for our clients, and we've shrunk the memory footprint by 3 to 4 times without sacrificing any accuracy on that particular set of data. And a great place to keep up to date on all of the new improvements here, I have to say, is like new embedding retrievers are coming online all the time. I like to use this massive text embedding benchmark that is hosted on Hugging Face, but as people like Niels Reimer who contributed to it. And it's a great place to see where all the newest and latest, greatest models are. This is, I took this, I think, a week ago. There might already be new models up there, but we keep an eye on this all the time to constantly improve our embedding systems. Now, the thing that really I'm excited about here actually is how can we combine the best of both worlds? And again, this is what we like to call hybrid retrieval. And this is where we try to combine both keyword and embedding search together, and then somehow combine these results from these two different streams to get like a better set of relevant documents. In this case, the magic sauce for us is this what we call the Reranker. These are typically cross-encoder models, but what they allow you to do is take multiple different sources of information and re-ranks them based on a comparison of the question and the document. So what it does is it basically says, it verifies if this question can be answered by this document, and it's typically much more powerful than an embedding retriever. So we find that these can still handle things like keyword search or these exact match overlaps. These are some models that we like to use. They're very small, they're very fast, so they're barely add any latency on top. We find that they work quite well. However, of course, these are standard benchmarks, so I also like to look into how well would it perform on something a bit more that resembles more of a production workload. So here we have a healthcare QA data set. It consists of 2,000 question answer pairs annotated by 15 experts on over 147 scientific articles. And the reason I call this this resembling a production workload is because now we have full articles that we have to then handle all the splitting and then the retrieval aspect. So it's not like these pre-made standard benchmarks where you have just one paragraph from Wikipedia. You actually have to handle like the full source file and then handle the retrieval through that, basically. And what I'd like to show you here, these are actual experiments we ran on our platform where we have this mean reciprocal rank. We look at the top 5 results to see if there's any relevant results in them. Keyword alone does okay, 72%. Embedding by itself actually does slightly worse than keyword, but then when we combine them together, we actually get a boost of 10%. So, and these are the reasons that we like to use this kind of hybrid retrieval approach as like our first step in tackling a new application to see how well it can retrieve results and push as many relevant documents as possible to the beginning of your search results. Now, of course, you have your retrieved documents, as we can see here, but you want to be able to present the answer to the user. Just presenting kind of a text blob to the user isn't necessarily the easiest to read, although some people might prefer that. So what we first have is something we like to call extractive QA. This is something we used more in the past. This is where you actually just directly highlight the answer in the text. And this is still relevant for some of our clients today who really care about exactly seeing where the answer is extracted from the source material. But it does come with its own sets of, pros and cons. But first, I'd like to talk about is how does the system work and look in total? So, of course, we still have our question here on the left. This goes into our retrieval system, whether it be hybrid or keyword or semantic. This retrieval system communicates with an external database. This is kind of like your knowledge store that you would supplement the LLM's knowledge with. Once you retrieve this information, you send it off towards the LLM, in this case, our extractive model, and then this outputs an answer for you. So the key thing being here is this new component we introduced, which is this LLM or extractive model. And the thing here is of course, what LLM to choose in this case. For extractive QA, the things that I consider are usually language, accuracy, and speed. Language, of course, we're a European company. We work with a lot of clients other than in English. So, we have a lot of German clients, for example. So, of course, we have to care and look for models that work in those languages. And a place that I like to start is looking at these Squad V2 leaderboard on Hugging Face. And then we have some models here that we like to use. And in fact, our model that we trained on this data set is the highest performing model on Hugging Face currently. So we like to start with these accurate models. And then if you care about speed and latency, you can go to smaller ones to try to speed those things up, of course, at the sacrifice of some accuracy. However, there are, like I said, some pros and cons of extractive QA. Some pros are the answer is highlighted directly in the source text, so it's immediately verifiable, which is quite nice. And each answer comes with its own relevance score, actually, that you can use in ranking. So you can actually feed many documents to the system, and it can rank the most relevant answers to the top. So you're less worried about it being confused by giving it too much context. However, some cons are that it is difficult to parse relevant answers. Of course, you have to see the highlighted answer and then read the context around it to really get a sense if it's the correct answer. And I know this is a very simple question, but in questions where, sometimes the answer is spread out across multiple sources, and that's kind of harder to parse with this kind of system. And the last thing here is that it's not really straightforward to predict no answer. And sometimes that's really important for these cases where you don't want the model or LLM to use its own knowledge to kind of tell you whether or not make up an answer, for example. And having it be able to predict that there is no answer provided in these retrieved documents can be a very powerful tool. And what I want to show you is that RAG QA can actually overcome these limitations in extractive QA. So how do you present the answer to the user with RAG QA? Again, we start with our same set of retrieved documents. We send it off to an LLM in this case, and you get your generated answer, which is what I showed before. And in this case, we're using generative models to do this and not extractive ones. Now, if we peel back the layers again and take a look at the whole system, we kind of have the question, the retriever again with your external database. But now we have two new components here. We have the prompt, which is, it goes into prompt engineering, and then we have that sent off to our LLM of choice, like things like Llama 2 or ChatGPT, which then synthesize, take that prompt and that context, synthesize an answer for the user. So, and now the question comes again, what LLM to choose for RAG QA, And there's a couple different things to consider here. Again, language, but we find that a lot of these, GPT-4, ChatGPT, these models actually handle multilingual quite well. We've used them for things like German. The next one is performance. In general, how well do these perform on benchmarks? It's a good first place to start. And then, of course, cost. A lot of these are behind third-party APIs, and you have to take into account how costly this is to be sending queries off to these APIs. It's a bit harder, I would say, to keep up to date with all the new models. A lot are coming out all the time. Some places I like to look at are this chatbot arena leaderboard, which I link here. And there's another one, of course, called the Open LLM leaderboard, but they don't have statistics on a closed source or third party, models from like OpenAI and places like that. So you have to look around other places for performance there. However, what I'd really do to really nail down which one you want to choose is kind of experiment with different providers to find out which works best for your use case. Standard benchmarks are great and all, but they don't always translate well to the best performance for your use case like RAG QA. And like I said, it can be a bit difficult to keep track of them all. You have OpenAI, Meta, Google, Cohere, Anthropic, open source, etc. And sometimes I would say, a big advantage is to use something like a model like Nasdaq platform where you can easily plug and play these different models. And this is something that DeepSet Cloud offers that has been quite exciting to work with, that we can plug in these models from these different providers and actually compare them directly to get a sense of how well they do. Now, of course, the other component I wanted to talk about is like, how do you build a prompt for these models? So, there are a lot of resources online. One I found particularly helpful is this prompt engineering guide, which I link in the slide. And another place that you can look is like kind of look for prompt hubs. So we have a Haystack prompt hub where we have a collection of prompts that users have liked to use and have succeeded in their use cases. But again, the best thing I can recommend here is to experiment and iterate quickly on different prompts and that best fit your use case. So one thing that we have here that I like to use a lot actually on our platform is called the Prompt Explorer. We can set up a pipeline for RAG QA, and then I can quickly iterate on the prompt down here and change it and edit it and rerun my queries to kind of get a sense of how well it's performing on these different sets of queries. And here's an example prompt that we like to use. This is a bit minimalized to make it easier to read, but it gives you the general idea. In this case, I had it answer in a journalistic tone for this kind of use case. And what we do here, and the thing I really want to emphasize is these text in green. This is how we actually insert the retrieved documents into our prompt. So we do it every time at query time. That's why we have this kind of thing that looks like a bit like code here, because we inject the documents that have been retrieved and we inject the question that was asked by the user into the prompt before it's sent off to the model in this case. And once you have that, then you can obviously get your answer. So of course, the things don't stop there. There are some other things that you have to take into consideration when you're using a system like RAG QA. One of those is challenges of incorporating relevant information, right? You probably have heard a lot about the context length, that term being thrown around a lot, and just basically means how much text can you fit into your prompt, and that can be understood by the LLM that you're using. What's great is a lot more models have been getting longer and longer context lengths. However, the longer context lengths do come with the penalty of latency. Those will take longer to compute and to get answers. The other thing that you have to take into consideration, there's been some recent research showing that even with these models that can have long context lengths, you can get a sacrifice in accuracy. So if your document, in this case, this graph is showing that if the document containing the answer is pushed further down the list of documents in your prompt, the reliability of the model gets worse and worse. It kind of has this weird shape where it, funnily enough, does better at the beginning, at the end, and kind of gets lost in the middle. So you have to keep this in mind when you're designing your system. And this is why we think something like information retrieval is so important, not only to improve cost and latency, but if you're confident that all of your relevant documents are within the first, 3 to 5 positions, you're going to get a boost in accuracy and in latency. So these are why, the retrieval system is extremely important for your RAG QA system as well. This might change over time. Models might continue to get faster and get better at using all of their context lengths, but this is kind of the reality at the current moment in time. And another great advantage of using a generative model that we've liked a lot is, what happens if there's no relevant information? What if a user asks, a very random or silly question? In this case, I have, did Atlantis vanish beneath the ocean depths? This is still in the same workspace that has all of the news documents. And in this case, the system will pick up a bunch of irrelevant documents. You can see here, maybe in tiny text, that the relevance is very low. But even if we send these irrelevant documents to our generative system, it's capable of determining that there's no answer in these documents. So this can be quite important in information-seeking cases where you don't want it to be creative. You want it to be very, by the book and respond with no answer in the cases where there is none in the retrieved documents. And the way we do this is by adding instructions to the prompt to say this when it knows that there's no answer, basically. Now, with a caveat, of course, this is not perfect. This doesn't always work in every case, but it continues to get better with more capable models coming out. So overall, what are the pros and cons of RAG QA? We have our generated answer. Some pros: it's easy to parse relevant answers across multiple documents. Very straightforward to predict no answer. Has access to up-to-date information through the retrieval augmentation. Some cons, but things that are actively being worked on. Sometimes it's more difficult to attribute sources used in the answer. But as you can kind of see here, and I allude to, is that we try to construct our prompts to provide references to documents retrieved, and that we've had some mixed success there so far. And sometimes the answers that can contain made-up information, hallucinations, which can be difficult to detect. But we're actively working on the system that will detect these hallucinations. And we actually have a previous talk on that from my colleague, Thomas, that I would definitely recommend checking out. Now, past all of these things, there's some other additional considerations I would say you need when building a pipeline like this. Of course, one of those is privacy considerations. So using third-party APIs, you always have to ensure your sensitive data is not being used for training. I know it's not the case now, but as a reminder, for example, ChatGPT through the API used to use data for training, and that was only changed back in March. So when it was first released earlier, that wasn't the case. Thankfully, it's different now, but these are things that you should take into account when using things like that. And another big one for us is actually, where is the data being sent geographically? So, for us in Europe, especially, we have to make sure the data stays within the EU. So we're often using places like Azure in this case to use OpenAI models so we can keep, these instances within the EU. Of course, there's another alternative here, which is self-hosting with open source models. You're given more control here. Data stays within your cloud. Quality of open source models like Llama 2 are starting to approach things like ChatGPT or GPT 3.5, not yet to GPT-4, I would say. And, one caveat to this, of course, is that it can be more costly in hardware and engineering time to host LLMs like Llama 2 using things like SageMaker, Hugging Face inference endpoints, or your own GPUs, basically. So those are all things to consider and are difficult. These are all different things that we support on DeepSet Cloud because we like to keep our options open and be a model agnostic platform. So we are looking at third-party APIs and self-hosting to take advantage of all of these things. And now a thing that I'd like to talk about that I've heard is a question that comes up a lot and often is talking about fine-tuning your own model and, taking an open source model like Llama 2 and maybe fine-tuning it instead. So fine-tuning, of course, is retraining a pre-trained model like Llama 2 to allow the model to adapt to your specific use case or your business needs, right? And there are some challenges to fine-tuning that I wanted to bring up. Gathering high-quality data for domain-specific instruction fine-tuning or reinforcement learning with human feedback can be expensive and time-consuming. Of course, not impossible, but it can take a while. And if you try to take this route without retrieval augmentation, so let's say fine-tuning your own model on your own data and then skip the retrieval augmentation bit, then an issue with that is you would still have to refine-tune your LLM every so often as new data comes in, right? Because of course, I can't know about the new stuff that's happened. So you're constantly kind of out of date, even with fine-tuning. And another thing to keep in mind is that better models are constantly being released, from OpenAI, Meta, Google, DeepMind, et cetera. And it could perform better out of the box than your fine-tuned model when it gets there with retrieval augmentation. And, to stay competitive, honestly, you would probably have to continue to refine tune as these new models come out, basically, if you want the best product. However, I will say there are times when fine-tuning could help. And it definitely could help if the original large language model is not well versed in a specific domain. For example, things like medicine and law, but even there, you have models like from Google now called MedPalm 2, for example, which would be a good thing to check out first, in my opinion. And one thing I would like to say is that even if you do use a fine-tuned LLM, you would still benefit from having something like retrieval augmentation on top of that, because you would then not need to retrain that model on newly added data, right? It would be more well-versed in like finance or law, but then as new data is added, it can just take from that knowledge database instead of relying on just training on that data. And another nice thing, as these systems continue to get better and RAG QA gets better, you provide sources to the generated answer, so it always is a way for the user to verify that the answer is correct, or if they want to see the source material to find other answers to other questions they have, they can. Finally, what I would like to do is wrap up with the last thing is that as a European company, of course, we're very interested in supporting multiple languages, not just English. And what I want to say is that there's a lot of models out there actually that can do this, and we can extend retrieval RAG QA systems to multiple languages quite easily. Some models that we use, I've put up here. These multilingual E5 base from Microsoft is extremely great. Supports over 90 languages, and there's a base size and large version of these models on Hugging Face. And in fact, for hybrid retrieval systems, we're using this multilingual Reranker trained, I believe, by Niels Weimer that supports over 14 languages. And what I'd like to add here at the end is that we found that generative LLMs, despite having a focus on English, also work in multiple languages, as you might have heard. In this case, I'm asking ChatGPT, can it speak German? And then yes, I can speak German, and how can I help, basically. All right. Thank you all for listening. I am open for questions.
Fantastic. Thanks a lot, Sebastian, for that talk. We do have a bunch of questions here that we've marked for you, so I'm just going to get started, right? So Auguzan is asking us, how does PCA on embedding retrievers work? Can you provide some sources for that?
Yes, definitely. So I believe we'll be able to share these slides after the talk. I apologize as I flip through.
There was also one about, who was it? I think someone was asking for the healthcare data set.
Right.
Yeah.
Okay, to quickly answer the question about PCA, I actually do provide a link here that goes directly to a training script, I believe, from Expert. So this is this is the one we've actually used in this case. And the way it works is you actually add an additional layer, in this case, a fully connected layer on top that projects your dimension down into a smaller one. So the typical size is 768, and we projected it down into 192, for example. And the way you train that last layer is you just take a bunch of your documents from like your target application, and you run PC on that. And this is in an unsupervised fashion. So it doesn't need to be any kind of like actual data you created. It just needs to have like examples of data that you'd like to retrieve from. So it's basically then preserving the semantics or like the embeddings of those documents. And we find a very low drop in accuracy, even being pretty aggressive for this. And we're doing this over, tens of millions of documents for the German legal domain. So that was our case, and it works still quite well. So hopefully that helps.
Got it. Now, Abhilash Kumar is asking, how do you push filter on metadata related to embedding vectors for user query?
Right. Okay. That's a great question. I actually almost built a slide for that. So let's see if I can just directly skip to that. So I apologize for the not great slide. However, what we do actually is there's two strategies we take. You can actually apply metadata filters in the same way as you do for keyword search. So you can apply it before or after the embedding lookup. However, one thing that we're exploring that works quite well is actually in the beginning of these documents, you can append things like metadata, at the beginning. In this case, it's rainforest. And this addition to the document, to the content, is added to every single document, but is never seen by the user. We only insert it right before it's embedded, and that's a way for us to take advantage of this kind of meta information. And it's something that's actually worked for us quite well. We've used it in a legal domain, often where the company name is defined once at the very beginning of the file of a 60-page PDF, and then you have to keep that knowledge present throughout the rest. So we do things like that to try to incorporate metadata as well. And we found it to be quite successful.
Awesome. We have another question from Ogusan here. So are you planning to incorporate the hybrid search supported by Pinecone and VAV8, like a reciprocal rank fusion?
Great question. That is something we were using before, actually. So we still use it today. We use reciprocal rank fusion to combine multiple sources as well to get a better ranking of our documents. We have found for a lot of our use cases that these re-rankers perform even better than reciprocal rank fusion, which is why we switched to those. But those are something we explore. We often compare the two approaches when we're approaching a new project or a new client to see which one works best for them.
Got it. Now we have a question from Eric here. Are there any effective domain-specific LLM QA techniques besides RAG, like RAG and fine-tuning, basically?
I mean, the easiest one, of course, is to find a model that's already been pre-trained on that type of data. So like I always take a look through open source models or what models are being offered by these providers. Unfortunately, it's a bit difficult in that approach because you're not always aware of which data that has been trained on for some of these models. But otherwise, I would say like different fine-tuning approaches would be something to look at. So like not everything needs to be basically from the ground up. Like you can try to, if your task is very specific and your data set's quite small, these things like, LoRa or stuff like that can still be quite effective in getting the model to perform better. Another one I would recommend is like few shot learning. So like if your task is like capable of being provided in examples for performing a certain task, few shot learning where you insert examples in the prompt is another effective way to getting it to like perform better without fine tuning, basically.
Got it. There are a couple of questions here where people are talking about like answer is getting completely messed up because the tokens keep getting truncated. Do you have something to add for that?
Yes, we do actually. That's something we're actively working on. I guess I can show. Where are we? Well, I'm definitely lost in my own talk. That's fine. I can just verbally explain. So what we like to do actually here is that, so the naive truncation is you truncate at the end, or you get an error saying like, okay, you went past the token limit, better luck next time, basically. So what we like to do actually is pre-compute the number of tokens that will be taken up. We can do this especially easily for, open source models or OpenAI models because they have their tick token library, which is all of their tokenizers. And what we do instead of truncating from the end of the prompt is we intelligently truncate the document. So we pre-compute how many tokens it's going to be. If it's going to go past that limit, we actually removed irrelevant documents from the bottom of the list to then fit back into the context. And then that way we're guaranteed that, it will pass and still have a good answer and not get kind of a mangled response. So that's what we like to do in this case. Implementing that kind of system is a bit more complicated, obviously, but is very worthwhile in our case.
Got it. Now Vijay is asking, can RAG QA substitute for fine tuning? I think you touched on that already, but.
Yeah, definitely. I think RAG QA can definitely be a substitute for fine tuning. I think the only caveat I would say there again is if the model is really non-versed in your domain, that could very well happen in very niche or very technical domains. But often is the case that we find that that's what we're doing. RAG QA is a good substitute for fine tuning and is a much more affordable and not necessary to gather any training data, right? You just need the data from the client or from whatever source and plug it in and it basically works.
Got it.
Yeah.
Yeah. Then there's a question from Sujit Pal over here. Oh, and it just disappeared. Okay. There are more questions coming in, so it just keeps going up and down. So can you talk a bit about the hybrid strategies? He says he's familiar with two-stage re-ranking, but he thought he saw cross-encoder mentioned somewhere in your presentation.
That's correct. Yeah. So yeah, so what we call here is the re-ranker, and the re-ranker for us is a cross-encoder in this case. So I guess this is kind of a form of two-stage of ranking, but in this case, we have two different streams. The keyword retriever and embedding retriever provides two lists of relevant documents. We just smash them into one list, send it off to a cross-encoder. The cross-encoder then re-ranks every document in that list, and based on the re-ranker's calculation of relevance, those get pushed to the top, basically. So that's what we're doing in this case. That's our version of two-stage retrieval, I would say.
Okay, then Matthew had a question similar, right? So he said, like, would applying a re-ranker after hybrid search be appropriate since the re-rankers are based on semantic meaning?
Yes, I think it is. I know there's the worry about like it not gaining the insights from the keyword in this case, but often what we do is we retrieve, let's say, 20 documents from the keyword, 20 documents from the embedding, we combine it into one list, and then the re-ranker, we say only give us the top 10. So we typically try to give the re-ranker more things to work with, and then reduce the number of documents sent off to the LLM after the fact, basically. So you're giving it a chance to see more context and then hopefully push these documents to the top. But yeah, that's what we do. But you're right, there's a danger with the keyword stuff being lost, but that's often, that's why we like to run experiments and check with numbers as well. If we have some sort of small eval set, if this is actually working, and we find that it does work in a lot of situations.
Got it. A quick one from Pradeep here. Does DeepSet provide the open source LLM interfacing and training? Does DeepSet provide the open source LLM interfacing and training platform?
We don't yet have full support for training. Those are things that we can definitely help you with in terms of the expertise for how to train and fine tune these models. But yeah, we have the ability to run any of these open source LLMs that you can find on Hugging Face. Those are things that we can do. So you can always test the RAG QA without fine tuning easily in DeepSet Cloud. And then the training aspect is a bit more boutique right now. Yeah.
Cool. Eric has another question. I think he had one before as well. So here he says, is there an approach for combining multiple kinds of models in a QA system? Like, for example, models that are good at understanding charts with models that are good at understanding text.
Yeah, that's a very interesting question. So that's something we've faced also with tables, even between text and tables, that can be quite difficult. I would say that's still being actively investigated by our team, and the best way to combine those results. In that case, I probably wouldn't use something like a re-ranker or even something like reciprocal rank fusion. In that case, you kind of almost want two separate streams, one about charts and one about text, and then provide both of those to the LLM for it to decide what is most relevant, basically. So there isn't one unified model or system that can probably understand everything other than the LLM itself, like GPT-4. So that's the approach we're taking right now, is we're kind of combining both streams, with a very small top K and setting it off basically for it to then synthesize the best answer that it can.
Got it. We have a question from Eric Botti. Do you have any advice for when to use differentiated methods of providing context to LLMs? For example, stuff versus MapReduce.
MapReduce. I can't say that I do. Can you repeat the question one more time?
Yeah, for sure. It's like, do you have any advice on when to use differentiated methods of providing context to LLM?
Okay, gotcha. Yeah, I unfortunately I'm less familiar with this aspect. I think I've heard inklings of this, but yeah, I don't have any good tips here.
Got it. Ogusan has a couple of more questions, so I'm just going to read both of them out together. So the first one is, have you ever experimented with split-generated sparse vectors? What's your opinion about them? And are we planning to incorporate it as a retriever? And the second one is how do big companies that want to host retrieval augmented generation on-prem handle hardware challenges? So these are like the two of them.
Those are great questions. Just to quickly get the first one out of the way, I haven't heard of that before, but I would be very interested in learning more about it. So please, let's save that so I can take a look. And two, for on-prem solutions, yeah. So, if you can convince that a VPC is good enough where you're still willing to use a cloud, but it is your own virtual private cloud, I would say that's probably the easiest option in terms of doing an on-prem solution. And that way, obviously, you have the hardware available to you through like AWS, Azure, or what have you. But for on-prem, for dealing with your own clusters and things like that, for RAG QA, my suggestion is, for everything up until the generated answer, you can basically accomplish with relatively reasonable hardware, I would say, right? These retrieval models are relatively small, and there's still a question of scale, so you might still struggle with many millions of documents. The issue really at hand is whether or not that the generative model, the LLM, like Llama 2, is so large that hosting it yourself is very much a challenge. It takes multiple GPUs basically to run it and run it well, and it requires these kind of like very specialized libraries. So that is the thing I would be most considerate is like, are you still willing to use a third-party API to send that out and use like a provider like Azure who might have a better reputation with like data security? But otherwise, yeah, I would investigate things like, HF, Hugging Face Inference is a good place to start, or like DeepSpeed and these other places to look at like how you would actually go about self-hosting these models. But in terms of buying hardware, you'd have to be practical with what hardware you can get your hands on, basically. There's a lot of GPU shortage for these high-end GPUs to do these kinds of hostings.
Cool. Now we have a question from Venkat. Again, it's a slightly longer one. So in the hybrid-based filtering, do the users have an option to choose the weightage for each type of search? Like in LangChain, he mentions we have ensemble. And in case of reciprocal rank fusion, how is it different from other vendors like Elasticsearch are offering?
Okay. So I'm not super familiar with the offerings from Elasticsearch in terms of for hybrid retrieval and combining multiple sources there. I know for like things like BM25, of course, you can do different weights and stuff. So we do allow you through Haystack to provide what we call a custom query, basically, where you can dictate the weights from different like metadata tags or like recentness, like time and things like that. And then in reciprocal rank, I believe we do allow you to like weight which source you rely on more. If you want the keyword search to be weighted higher or the embedding search to be weighted higher, we do allow that through our like join node in this case. So those are definitely things in terms of like what we offer on top of. I mean, like we're using services like Elasticsearch or OpenSearch and these things in combination with vector databases to do this kind of stuff. I'm not fully aware of the stuff they have built in already for these things, and those are things that we're going to keep an eye on. But yeah, we do a lot of this recombination ourselves and through Haystack, basically.
Okay, got it. I'm just looking at like there's a bunch of other questions. So Eric is okay. Many people have asked something. So many people have asked here how to set up a generative QA solution that would handle both like text and tables. Just to capture like a few of them together. So what do you think about that?
Like how would I go about building a system that can handle both, basically?
Yeah.
Yeah. So there's a couple of interesting steps here, I would definitely say. So like one big step is extraction of data. So like, can you like, is a question like, are PDFs and you have to extract tables from PDFs? If that's the case, I would definitely look at good extraction techniques. There are a lot of good closed source providers for that. But let's pass that step. Let's say you have your tables, you have your text, and then you want to combine the retrieval system here. So that one's still definitely a question and a struggle. Sometimes, like if the tables are really embedded within the text, we like to keep them kind of linked together. So like we'll restrict results coming from like the same PDF and things like that to kind of like keep the context around the table, or use things from the table like the title or the description and stuff like that as part of the retrieval method, basically. to provide to the model. So you use that textual information to decide whether or not it needs to be seen by the LLM, basically. In terms of scaling that up to like even larger tables where you might want something like an SQL database, that's something we're still actively investigating and using techniques like, LLM, like text to SQL for that kind of stuff. But yeah, I don't have anything definitive there yet, I would say.
We have a question from Avinash. Do you have any scaling benchmarks for a Q&A system? They've faced issues while scaling recently, it seems.
Gotcha. Scaling benchmarks. I know we are starting to publish benchmarks on Haystack, and I will have to check with my team where we're at on those, but we are trying to provide some of those benchmarks through that. And we'll have to see if something like the data or the stuff we're using to benchmark is available. But yeah, I'd have to get back to you on that.
Okay. We have another question from Eric. Do customers find a big benefit of RAG QA over traditional search? Is the LLM basically a natural language interface for traditional search, or does it offer any new capability?
Yeah, it's definitely what you want to use it for at the end of the day, right? So I would say yes and no. So for like these single kind of responses, like it is a natural language interface which provides the ability to summarize and take information from multiple sources. Something I didn't highlight here, but people are actively using are things like what we like to call a diversity ranker, where you take multiple different multiple different sources to provide a higher level overview of a field, and then you use something like an LLM to synthesize an answer there that's more coherent than you having to read every separate article. So I would say that's definitely a huge advantage. And another advantage that people are using and that we like to use is like the ability to ask follow-up questions or redos and things like that, and keep the previous context basically. And those are both things that like an LLM can do that a traditional search system obviously can't do. So those are things that we like. However, there are people who are very much interested in the more traditional search-like experience. We've worked with legal clients who very much like seeing like just the documents or seeing the highlighted answers, because for them, they want to open the file and read the file, and that's what's relevant to them. So I think like keeping it flexible and keeping the ability open is quite advantageous, I would say.
Got it. Yeah, we have another question here. Then, what generative QA output evaluation methods and metrics would you recommend in general?
In general, so definitely for retrieval metrics, things like mean reciprocal rank, that's a very good one. Recall as well, where you can just check if there's a relevant document in the top K that you're checking. Those are probably the most relevant ones. I mean, there's a lot more zoo of metrics basically, but those are two ones I often look at for retrieval, just making sure that you have very relevant answers near the top. For the LLM, when it comes to like the generative model, that one's a lot more difficult. What I would recommend there really is to get it into the hands of end users and provide ways to provide feedback so you can check how well it's performing in terms of accuracy and relevancy in its answers and questions. I know there are methods out there for doing kind of auto evaluations based on things like GPT-4 and stuff. We're keeping an eye on that. However, there is an issue with it. It's shown to have like, for example, there's a paper that recently came out that shows it has a bias towards models trained on outputs from GPT-4 or ChatGPT, right? And that's just a little problematic in terms of being confident that the system is working as well as you want it to. The other thing I'd recommend finally is like looking into these hallucination detection. These are something we're actively working on and implementing ourselves, where you can basically at the end of the day judge if each sentence in your answer is verifiable by the documents you retrieved, and then you can kind of have a groundedness score to say that this answer contains all truthful information and stuff like that. And that'd be another good way I would say to check these systems.
Got it. So there's another question by Rohit here. I'm not sure if you're familiar with this, but do we have any plans to integrate with unstructured IO for dealing with multiple documents?
I'm not too familiar with that. I would say that sounds like it would be an integration with another library, which would be great. I haven't heard of it as before, so I'd like to take a look into it. But that's something that our core team that works on Haystack is constantly looking at to add integrations and ways that we can collaborate with the community. So yeah, I work more on the client side, so I'm a little less familiar with all of those, the active developments there, but that would be a good place to check, I would say.
Okay. We have another question from Oguzhan here. So pre-processing unstructured data formats such as Word, files, PDF, etc. are painful.
Yep.
So do you have any tips and tricks or some techniques that you've used before, like besides Haystack's defined preprocessor?
Yes, so that's just a thing we want to expand definitely in Haystack as well, but utilizing things like the structure of the document, like Markdown, for example, keeping sections preserved or splitting based off of header, splitting based off on paragraphs. So you want to keep this context well preserved. I would say that is a strategy we've employed a lot to great success, is keeping like sections like kind of like first split up sections, and if they need to be further split, you can. I would heavily recommend adding things like overlap. So when you do splitting, don't just split two separate, like a split one paragraph into two separate ones. But if you add some overlap between the documents, there is some redundancy, but that helps in context. Another popular one that I've seen people have been using is that, once you retrieve the document, you go back and you repopulate context around it to provide a better way to provide more context to the LLM. So I would say those are things to look at for sure. Honestly, it's a lot of experimentation and looking at your output. So inspecting your output after pre-processing and seeing if you're happy with those things is something I would heavily recommend and has saved us a lot in a lot of cases. I know, for example, PDF parsing is a real pain. And often it comes down to like, are you using the right settings for your PDF converter? Because there are different settings that are optimized for 2-column versus single column format, or from like the way it detects if things are on one line or not. And I recently came across that, and I had to use OCR from PyTesseract, and I twiddling some settings around made the results loads better, basically. So the ability to inspect and iterate and improve, I would say, is like a huge one. It's kind of hard right now to have a one size fits all. You probably can find one through paid services. Like there's some pretty good ones for PDF conversion, but it's a question of, again, of whether or not you want to use paid service or open source.
Got it. There's one by Ala now, a question like, what is the average number of top similar, what is this? What is the average number of top similar chunks should we use? As you explain, the increasing number may degrade the performance, but the answer may be in the last chunk, right?
Right. Yep. So yeah, that's a good one. The scientist in me would really want to figure out, like, if you were to give it more, have a way of checking your answers. Again, that is a bit manual right now in terms of whether or not the answer is being picked up properly. That's why the strategy we've kind of employed is like really focusing on retrieval metrics and seeing if we can push the retrieval metrics to higher and higher, so we're confident that the answer will appear within like the first 3 to 5 slots. That's like the strategy we like to employ right now. However, there are some other things we've looked at. So we've recently implemented, and I think a lot of people have, called lost in the middle ranker, where we actually put the relevant documents at the beginning and the end, and all the least relevant ones in the middle, to kind of like mitigate this to some degree. Yeah, so like I think those would be the 2 ways I would take a look at that.
Got it. Okay, marking this away. We have a question from Eric again. Is it possible to use RAG QA to answer questions that are not in the document database? For example, if we ask, how far can a human throw a can of Coke? When that particular answer is not in the database, but there is information about the weight of a can and human strength that can be synthesized into an answer.
That's a great question. I think that will come down a lot to how prompt engineering, I would say, like how you want to have the model basically instruct the model how you would like it to answer. So like, of course, you can tell it to answer questions that it's fairly confident about, and iterate on what wording best gets you that gets you there. Other ways, in your specific case of like, you can retrieve more information or have the model retrieve more information, looking like at a conversational agent system would also be very interesting there, to see if it would be able to answer the question then, if it could find other relevant information from your database. So I would definitely take a look at that as well. Yeah, in our case, we specifically said, if you can't answer the question right away, provide no answer, but you can be way more flexible than that, obviously, with whatever you want to put into the prompt.
Got it. A quick question, I think, from Sujit, like, do we have any plans of integrating with a Vespa data store?
So that's a good question. I think that goes back to, again, with we all of our technology on DeepSet Cloud is built off of Haystack. You know, in terms of our NLP stack, basically, and that all of our integrations are with Haystack. So I would definitely take a look at there. We have like an integrations page now where we have a lot of document stores that we have supported. I don't know if Vespa's yet on that list, but if you add an issue to our GitHub, that would definitely be something that people would be interested in picking up, I think.
Okay. Then we had a question asked a little bit earlier from Plaban, like, can we store images as a metadata in the vector store?
I think it heavily depends on the vector store you're using. I guess would probably be not in a lot of cases, at least metadata with the vector stores that I've worked with is required it to be text. You could always refer to the image location in that metadata, but I don't think you can store the actual image itself there.
Got it. Maybe we can take like maybe a couple of last questions. So when implementing RAG QA, how can we minimize the risk of hallucination in the generated answers? Did we
So
cover
yeah,
that?
I think already using retrieval augmentation is a huge boon there, and then providing examples in the prompt about like ways that it should not answer. So like this ability to say that there is no relevant answer, I think already mitigates this by a lot. The next step there that we're also working on, like I said, is this hallucination detection, where we use like a natural language inference model basically to verify that the answer itself is present in the documents that have been retrieved and produce like basically is it fully supported. In this case, I think they often like to say contradiction neutral or fully supported basically, and using that kind of system to then better verify and more automatically verify your answers. So take a look at that. There is some open research on that, and people are actively doing that. In fact, one of our colleagues on the Haystack team, Stefano, had like a fact check verification talk and project, and he has a node for that in Haystack. So you can check that. We're trying to expand that a bit in DeepSet Cloud right now, but that would be a way to definitely take a look.
Sounds good. Yeah, I think that'll do us for today. So if because you mentioned a lot of like resources, I encourage everybody who's still listening to please have a look at like deepset.ai, and we have a webinar section over there. And you can find a lot of like these older webinars. So please go and check them out. And of course, we'll have like a small feedback for all of you at the end of this. So please do also fill that out. It really helps us kind of calibrate these webinars going forward, and we actually do use a lot of that feedback to plan new content, so please use it. And thank you so much, Sebastian, for the wonderful talk and a very intense Q&A. I have to say it was there were a lot of questions, and in case you didn't notice, like we had Elena in the background who was also answering a lot of those questions for you guys, so thank you so much, Elena, as well for helping out with the Q&A section. So we will have our upcoming webinar in the coming months. So thank you so much for everyone who stayed till the end. Thanks again, Sebastian. And I guess we can close it there for today.
Thanks a lot, everybody.
Thank you. See you. Bye-bye.